Hello people, this is part 5 of the Minesweeper mini-series on this channel. So this video is a little different. We're not going to, well, not in my PowerPoint presentation anymore. I'm playing a Minesweeper game now. So this is an example game. Well, this episode is dedicated to play an example game. But this time we're playing on the hardest difficulty, Evil. Since we basically know everything what we need to know to solve any game now, it should be also solvable with the techniques that we've learned from the previous videos. So let's start solving. So we can start off with the basic techniques that we've learned from the first video, where we have the same amount of adjacent cells as the number, which means all of them are mines. And then we can clear out squares. I'm going to be a little slower here, maybe, because we have more time, because, well, this video is dedicated for the example game. So it can take a time. Here you can use reduction, because these two cells are inside the field of this cell, or of this number here, which means that the mine is somewhere in these two cells, which means these are free. Reduction again. You can use reduction again, freeing the two here. These are free cells in. Reduction yet again. Let's see. Okay, here's a little complicated. We have a 3 here and a 4 here. Now the 3 here says that these two cells here have one mine, because we have a 3 here, which means at maximum these can have one mine. You can also have no mine. The 4 here says that we have 2 mines here, right? In these squares, right? We have 1 mine here and 1 mine in here, in these 2 cells, right? The 3 here says we have 1 mine in all these cells. We know from the 4 that these 2 cells have a mine, which means these 2 cells are free. Here was merging, since there's a 1 and there's a 2 here. Reduction. Now I'm not going to say the techniques now all the time, because I think these should be pretty much embedded now. Like, they should be clear, so I'm not going to say it all the time. I'm going to say it when it's not obvious. There we go. This side is done. Now we have 1 mine in these 2, and we expect 1 mine in all of these 5 cells. We know that there is 1 mine in these 2 cells, which means these cells are free. We have 1 mine in these 2 cells, which means for this free here to be, well, to work, these 2 cells need to have a mine, so that the 3rd cell is somewhere in here. Here you can use merging and reduction, merge and reduction. Here we have 1 mine here, which means for this 2 to work, we need to have another mine here somewhere. That means that for this 2 here, these 2 cells are free. We can use reduction again. Merging and then reduction. This is So it's tempting to press it, but this should be left for the end of the game, because notice we know the amount of mines that we have. So when we solve everything else, as long as we don't have another situation like this, we should be able to tell if there is a mine or not. So let's ignore it for now. That's reduction. Okay. Here we have a interesting situation. We have a 4 here, which means there is a mine in here. And we have a 3 here, which means there is a mine here and 1 mine in these 3 cells here. This 2 here says there is a mine in these 3 cells because of the 3 here, and there is 1 mine in all of these 3 cells here, which means these 3 cells have 1 mine. So this 3 here, so for it to work, these 2 cells have to have a mine. So let's place these 2 cells. So these 2 cells have mines, and we can continue. We have 2 mines in here, which means this is 3. And we are at the other edge. I think we are slowly halfway done, I think. I don't know, how many mines do we have? Well, does this game have? Oh, no, actually, we are about 2/3 done now. All right, that was reduction, and then we can do reduction again because of this one here, right? Now this 2 here has 1 mine here, which means these 2 cells needs to be mines for this 4 to work here. Now, as you can see, the reduction and merging stuff, they don't really matter as much in the more advanced games, because in the end, we're just doing the combination stuff. We're just thinking about what cells have what mines, right? I came up with the whole reduction stuff and the merging stuff to help beginners more with imagining what is going on and how to solve more complex situations. All right, we have 0 mines, which means this is not a mine, and we're done. Yeah. Yeah. So that's that.